Hey, everybody, this is Jeff Kelly. I am speaking with Frank McQuillan, who is Director of Product Management for Analytics and Data Science here at Pivotal. We're going to talk a little bit about graph analytics. Frank, thanks for joining us.
My pleasure, Jeff. Nice to be here.
So I read that graph databases are one of the fastest growing categories of databases. I think that was according to DB Engines, and they're pretty reputable and well known for those types of numbers. Why are graph databases and graph analytics so hot right now, in your opinion?
Yeah, you're right. They are hot, Jeff. And I would say that there's a growing number of modern business problems in analytics that are about connections and relationships and not just discrete data. And graphs, not surprisingly, are a very good way to represent these connections and relationships. So people have been building tooling in this area in the last few years. And as you say, if you look at these database ranking sites, you'll see 20 or more graph databases or graph-related kinds of databases there.
So you mentioned they're good for analyzing relationships between entities. Could you talk a little bit more about some of the killer use cases?
Sure. Well, social networks are the classic one. So let's start there. And the kinds of queries that you may want to run on a social network include things like content recommendations or friend-to-friend recommendations. You may also want to know who the influencers are in a social network. That is, who are the people where most of the information or a lot of the information flows through because they have these vibrant connections. Another example is fraud detection. In the area of money laundering, e-commerce fraud, criminal networks, insurance fraud, often they use a link analysis kinds of algorithms to discover fraud. And I'm thinking, for example, of the Panama Papers, which we all have heard about recently, or in the last year or two. And graph databases and processing were actually used as part of the analysis of that data. And other common use cases in the area of autonomous vehicles for route planning. If you look at a map, that's naturally described as a graph. So if you want to figure out how to get from where you are to your favorite coffee shop, then that is a route planning problem that lends itself to kind of a graph representation and graph analytics. And in fact, any, domain in which these connections or relationships are key, like master data management, telecom networks, there are many places in which graph analytics can be applied very effectively.
Right, that makes a lot of sense. And I think we can relate to some of those, certainly to some of those examples. Now, considering that I am not a data scientist myself, I wonder if you could explain in layman's terms how graph analytics actually works.
Sure, I'll try.
Easy question, right?
So you start with the graph, which has vertices and edges, right? So vertex, some people also call these nodes. They can be people, they can be towns or intersections on a map, they could be components on a printed circuit board. And then you have edges, which connect these things together. And edges can have direction or value associated with them. For example, how many times two people have talked, or how long it takes to drive from one town to another. The other interesting thing about edges is they may have properties associated with them. And a property, for example, is like, is a member of, as in Jeff is a member of the debate club or the math club, right? So we have vertices and edges that gives us this graph representation. So you asked about what the analytics are. So the graph analytics are actually algorithms which operate on this graph data structure, however it is represented in the computer, in order to answer some question of interest. The shortest path one, the most influential person in fan base in New York Yankees, or what have you. And these algorithms are, it's hard to characterize them, I think, in a simple way. They're many and varied, and they've been actually the subject of a lot of academic research over the last 40 to 50 years, and are being applied now in these kind of more modern use cases, you could say.
Mm-hmm. And how would you size up the market right now? You mentioned earlier that, of course, there's a number of specific graph databases that are specific to graph analytics. Then we've got more general purpose databases that do graph analytics among a number of other things. I think Greenplum would probably fall into that category. It has some graph capabilities, but it's also, a full-featured analytical database. So you've got those two different approaches. Of course, you've got different vendors supporting these different types of databases, some open source, some not. How would you size up the market right now?
Yeah, well, as you've hinted, the landscape is complex,
Right.
as you might expect or fear. There are a number of these purpose-built graph databases. So Neo4j is perhaps the most popular one. People may have heard of that. Other databases people may have heard of are Titan and Giraffe, Apache Giraffe. These are in what I would call like a general operational category of graphs in which they can solve for a bunch of different graph problems. Then there's also more specialized graph databases. I'm thinking of semantic search, for example. There's databases like Virtuoso, which are good at searching through semantic data, like the example we were giving before. Jeff is a member of the debate club. Those kinds of queries, those databases are effective at. There's this area of kind of multimodal databases, which combine graph with other capabilities like a document store or a key value store. Microsoft has a product named Cosmos in that category. And then, apart from the graph-specific ones, then as you said, there are relational databases where graph processing is done using standard SQL or with built-in libraries, which we're going to talk about in a minute, that can be called with standard SQL. So there's this kind of whole landscape out there of different graph, open source, and vendor-specific vendor products.
Right, and so that strikes me as it might be a little bit challenging for a practitioner to master the different ways to interact with these different databases. So, do you need special skills to run graph analytics? Is there a SQL language for graph analytics, something that's standard that all data scientists and analysts can learn? Something like Cypher, for example?
Yeah, so there are possibly skills that one would need to develop. So Cypher, which you mentioned, that's a query language for Neo4j, which is inspired by SQL. It looks a bit like ASCII art to me, describing relationships between vertices. That's widely used. There's something called Sparkle, and Sparkle is in this category of semantic query that we were talking about earlier. So if you want to query these subject, predicate, object sorts of things, Jeff's a member of the debate club, this guy has a color of blue, etc., those sorts of queries, then Sparkle is very good at that. Those are people call those RDF triples in graph lingo. So there is some standardization, but some learning that one would need to do in order to kind of work on those databases. In the case of relational databases, there can be less of a learning curve because if you're familiar with SQL, then you can run graph queries without new skills. Of course, you need to kind of understand the concept of a graph and what you're trying to query. But in terms of the mechanics of the query, that could be more familiar with SQL.
So turning our attention to Greenplum specifically, give us a little bit of the history. How long has Greenplum included some of these graph analytic capabilities? Maybe describe a little bit what those are. And really, what was the impetus for developing it? Was it simply that graph analytics was becoming more popular and therefore it was something you wanted to build into the product? Give us that history.
Yeah, it was partly that. We started developing graph on Greenplum 12 to 15 months ago. And we did it as part of the Apache MADlb project, which is, so Apache MADlib is a top level Apache project. It's an in-database machine learning, statistics, math package. It runs on Greenplum, parallel database. It also runs on SQL. So in that time, we've built up a pretty good library of about a dozen commonly used algorithms. You asked about the motivation. Well, the motivation came partly from our customers, but also from the realization that it's hard to move, it's expensive to move data out of the database into a separate graph execution engine, move the result set back. So we wanted to eliminate that data movement by bringing the compute to where the data resides. So bringing the graph computations to where the data lives in Greenplum. In addition, in conversations with our data science colleagues here, we realized that many data science problems are practically solved by an ensemble of models, right? So graph being just one of them. So if you can do your graph computations in the same place that you're running regression or clustering, other data cleansing kinds of algorithms, which Greenplum is great at, then it's convenient and it's less expensive as well.
Right. I was going to actually ask, what are some of the benefits of that approach of including graph analytics in a larger database structure versus having that specialized graph analytics database? It sounds like one is that data movement. You don't have to deal with that. You've also got the complementary analytics capabilities built right in.
Yeah.
And oftentimes those are used in conjunction.
Yeah.
And obviously it's just one less, piece of software that you have to manage.
Right. There are trade-offs, of course, because you don't, get everything by working in a relational database, even with parallel compute capabilities like Greenplum does. So, people write papers on this topic, but in my mind, the key points of why do you want to do graph in a relational database, you touched on some of them: cost of moving data. It's just easier on your DBA for management and upgrades. There's one fewer database in the picture, one less vendor in the picture. I would say a couple of key ones are SQL familiarity, because it's just the most common workload in the enterprise, and scale. Parallel databases like Greenplum, they allow you to run a certain class of algorithms on large graphs with predictable scaling. And they can take advantage of, decades of research and development in the area of query optimization and query execution. Right? So these databases are very good at efficiently running queries on large data sets. So you can take advantage of that scale capability within MADlb. And the approach, MADlb on Greenplum, and the approach that we take to do that, we use something called vertex-centric processing. And the idea, it's a way of approaching graph analytics that kind of makes it amenable to working in a distributed system like Greenplum. But, just to finish on this topic, graph databases exist for a reason. I mean, they're very good at certain things. They're very good at representing properties. I think properties can be represented more naturally in graph databases. Semantic queries can be expressed a little bit more simply. And also, when it comes to efficiency, we said there's a class of graph algorithms that work well on MPP databases, but not all. So semantic queries that involve that would result in tons of joins or table scans in a relational database, those can be very compute and memory intensive. So we have to be careful about what we decide is going to work in an MPP database at scale.
So looking forward, what are some of the things you're looking to add to Greenplum's repertoire this year, whether it's from graph analytics perspective or maybe some other functions? Right.
Well, we just released Apache MADlb 1.13, which has graph analytics, runs on Greenplum 5, Greenplum 4.x, so the newest versions of Greenplum. It's got, as I said, about a dozen widely used graph algorithms, things like PageRank, shortest path, graph diameter, these sorts of things. We're working on the next release now, which is 1.14. And we're going to be adding additional graph capabilities there. One example is we're working on something called centrality measures. One of them is between the centrality. So this is a way of quantifying how much information passes through a given vertex. So this can help us understand the influencer question in certain networks. And we're also working on a new version of PageRank, which is more personalized. So it's biased a bit towards more local vertices. And the result is that you end up with more relevant or personal kinds of recommendations, right? So more graph, as well as continuing to build out more utilities for operating on data sets and extending the existing machine learning library in Greenplum using Apache MADlb.
Great. Sounds like you've got a busy year ahead. So wrapping up, I know that we've got a big event coming up in a couple months now, Greenplum Summit, which I think is part of PGConf.
Yes.
Tell people about that. What can attendees expect at that event?
Right. So PGConf it runs April 16th to 20th. It's in Jersey City. And as you said, there's a Greenplum Summit there focused on Greenplum database, which is on the Thursday, which is April the 19th. So one would expect there throughout the day, wide range of business and technical sessions, and that should appeal to a wide audience. I guess folks interested in parallel databases and all the great things you can do with them from the kind of technical perspective through to business applications.
Well, great. Well, if you're attending that event, everybody watching, definitely swing by the Greenplum Summit. I think it's going to be a good event, both if you're new to Greenplum or if you're a hardened user. So, well, Frank, thanks a lot. This is really informative around graph analytics. We'll have to catch up again soon because it sounds like you guys have a lot you're working on. So I'm sure there's going to be more to talk about soon. But thanks for taking the time. Appreciate it.
Thank you, Jeff.